Class 12. Let's start to understand the part of rate of reaction. So rate of reactions are of two types: average rate of reaction and instantaneous rate of reaction. Recently we have studied how to calculate the rate of reaction by using the term change in concentration per unit time. So let us consider the number of reactions takes place in different manners. Suppose you are mixing two substances, suddenly they give a result, and sometimes the reaction takes long time, sometimes the reaction completed in 24 hours, we get the result on the next day. So on that basis, the rate of reaction have been divided into two main parts. One is to be average and second is to be instantaneous. Average reaction means rate of reaction measured over a long interval of time. Okay, so let us consider A is a reactant and P is the product. So always we know that whenever the product starts to form, the concentration of reactant start to decrease, so it is to be denoted by negative sign. And when the rate of reaction is to be measured over a long interval of time or the large gap of time, the sign of delta is to be denoted, delta A upon delta T. This is change in time, this is change in concentration. Okay, and triangle, that is the sign of delta, that denotes the change in concentration for a long interval of time. Instantaneous rate of reaction means instant. Instant means suppose you are mixing together, suddenly we get a result. Okay, suppose you are showing acetic acid with ethanol, suddenly it forms ester. It doesn't take too much time. So instant reaction that takes place or that completes into 1 or 2 seconds or few minutes. Okay, so the rate of reaction measured over a short interval of time, these are to be considered as instantaneous rate of reaction. Let us consider A is a reactant, P is a product. So in terms of A, as we are forming the rate of reaction, so rate of reaction that becomes negative dA upon dt. Negative sign we have put because the concentration of A is going to decrease. Instantaneous, for instant result we are getting, so it is to be denoted by D, not for delta. So here we must have to understand the difference. When the large time gap, it is to be denoted by triangle, and whenever the instant reaction takes place, it is to be denoted by D. Okay, so now here I am just telling to you rate of appearance and disappearance. Let us once again consider A is a reactant, P product is forming. So rate of disappearance. Disappearance means whose concentration will disappear as the product starts to increase in formation. Okay, so A start to decrease, so decrease in concentration of A, here I have written, so it's in the term of instantaneous rate of reaction dA upon dt, and that is to be mentioned with the negative sign because decrease in concentration. Rate of appearance, that always takes place in the form of or in the term of product. So here it is not decrease in concentration of P, here it is increase in concentration of P. Here you have to write increase in concentration of P. So here I have written there the sign positive dP upon dt. Okay, so that's all for today. That was a general introduction of the chapter chemical kinetics, and in our next topic we will study in detail how to find out the rate of reaction or the chemical changes occurs in a chemical reaction. Okay, so you have to prepare notes in the homework and kindly share in the homework group. That's why I have to check your mistakes. That's all for today.